Hello, it's Scott Manley here, and today I am flying the Dreamchaser in Kerbal Space Program. Actually, that's not the Dreamchaser at all. That is some vague approximation I have thrown together to let me demonstrate a bunch of different mods that I've been using. So yeah, this is all built from Spaceplane Plus parts in 0.25. This is horrifically unstable early in the atmosphere because the centre of lift is so far forward. Even with relatively large wings on that tail section, you see that I have to have RCS with Werner thrusters to keep the thing flying straight just in case it goes off centre. Even then, if I let this deviate more than about 10 degrees from the velocity vector, it will flip out and I will not go to space yet. I will not go to space today, let's say. So yeah, obviously that's the plan. Once we're up in space, once we get out of the atmosphere, we can point this in whatever direction we like with impunity, because the atmosphere is what is providing these aerodynamic problems that will soon be our saviour when we're returning. Incidentally, you know, it's aerodynamics that defines the line of entry into space. There's something called the Kármán line. The Kármán line is essentially the altitude at which a wing would have to be travelling at orbital velocity to generate enough lift. So it's kind of the definitive transition from aircraft speeds to orbital speeds. Anyway, yeah, this thing is going to get up into orbit, and I'm just going to make sure that I'm pointing correctly. Now you can see here the red line of the trajectories mod. That's going to be helpful later on, but also I want to show you the nav HUD. This is a mod which lets you project your navigation information over third-person view. So perhaps if you want to get rid of the nav ball and reacquire that piece of screen real estate, then yeah, you can see all the information you would get on there. That, yeah, we're just getting into orbit nicely. It doesn't actually show you what my apoapse is, which would be a nice thing to do. I have MechJeb installed on this spacecraft here, but I'm not using it. I'm flying into orbit manually. Yeah, the idea behind the nav HUD is that it lets you see all the stuff you would see on the HUD more or less, but without having the nav ball shown. So it's helpful in a lot of ways. In particular, it does help you visualize your velocity vector relative to real objects. So it's kind of useful if you're perhaps trying to glide into a specific runway. You just put your velocity vector on the runway and that's where you'll land. Similarly, you can use it to figure out where you're going to land on the moon or whatever, just by looking at where your velocity vector is pointing. Anyway, I'm not going to use that. Let's get back and bring up the nav ball, turn that off, and we're going to get ourselves into orbit. So we need to get ourselves up to 100 kilometers. I can hear the sound of space. We have clearly crossed the threshold from atmospheric to vacuum. Anyway, so yeah, this is the velocity, the trajectories calculator. What it does is, along the red line, it is calculating your orbit with the accounting for the atmosphere. So that red cross is telling you where you're going to impact, and that is different from where the orbit is because it's accounting for the rotation of the planet. Obviously, that's an exceptionally useful tool to have if you're trying to recover your spacecraft and you want them to land near Kerbal Space Center. It works with Ferrum Aerospace and NEAR and with the stock aerodynamics. But we're here, let's accelerate our engines, fire our engines, and now fire up the main engines of this little space plane. Just a little LV-909 to accelerate us up to orbital velocity. I think we have about 1.3 kilometers per second of delta V, so not really enough to do anything but maneuver in low curb in orbit. But that's all we need. You know, I guess technically we can use this on return as well if we want to fly through the atmosphere, but ideally we do not want to do that. Okay. So we're getting close. We're starting to lose our vertical speed. I'd like to get this orbit as circular as possible. 1.9 kilometers per second, and we're starting to fall back. So let's lift our nose up just a little. 1 and 2 kilometers per second. Now, there we go. 2 kilometers per second. Excellent. And we're starting to fall down just a little. But you can see this red line getting predicted. The re-entry orbit is getting predicted further and further away, which is a good sign. Eventually, we want the whole red line to disappear and just have a white line, indicating that we are in a stable orbit. And there we go, we are in orbit, finally. So now, once we cut our engines, we can begin to perform our mission. So the mission of this is to launch a small payload into orbit. Obviously, this isn't like the real Dreamchaser, which was supposed to be a crew transfer vehicle, but this is nice and lightweight. This is a little spacecraft, a little ion-powered space probe, and unfortunately I forgot to actually include an action group, so I have to manually fold out all these little solar panels so that it can begin its mission. But mission to where? Well, with an ion engine it can go quite a long way. It can go to almost any planet in the Kerbal system, I would imagine. And we come down to the classic question that gets asked all the time. How do you figure out where you're going to go? How do you figure out when you're going to other planets, right? So, say, we all know about the orbit phasing, right? We know that if we want to go to Eve here, we want to wait for it to be there, and then we will perform our deorbit burn that will bring us to an encounter there, right? So you can calculate the relative phases, the relative change of angle, and figure out at what date your orbits will be lined up. Now, for elliptical orbits, it's slightly more complicated, but you can still figure that out. And for inclined orbits, you can also still use that same approximation. But here's a mod, the Transfer Window Planner, which will figure out not just the windows, but the best windows. So you set your target in here, you tell it you want to find a window before year 3, and it generates this nice looking diagram here. Now it's color coded. Along the bottom you have your departure date, and up the left side you have your travel days. And so what it does is it calculates the orbit requirements for each of these combinations. So it knows where you start and where you end, and then it plots an orbit between them and figures out the delta V requirement, and that is converted to a color coded value on the left. So you can see at the low end it's about 2.7 kilometers per second. At the high end it's like 25 kilometers per second, right? So you can take these numbers and put them into your into like a Kerbal alarm clock, and then calculate your orbit when it's there. Okay, so say we're going to Dres. It's more interesting because its orbit is more eccentric. So you get a window at 343 days, which will take it'll take 1 year, 156 days, and it'll cost you 4 kilometers per second of delta V. See, the blue there is the lowest delta V requirement, and that includes your ejection velocity and your capture, your insertion burn requirements. Now, of course, I can do this using the existing Kerbal alarm clock. I can say, give me a transfer to Dres, and overshot, wait a second, Dres, calculate that, and it says 419 days, so it's picked a completely different date. They're pretty close, but the alarm clock is using a much simpler approximation, and it isn't going for the minimum delta V requirement. I'm sure we could actually put something on that date and it would figure it out, but if we extend out our window to 5 years, it then points out that wait, if we wait until year 3, day 121, there's there's an orbit that will only need about 3 kilometers per second, just over 3 kilometers per second of delta V. So that's clearly a better choice. Efficiency in space travel is much more important than time almost always, until you have crew, in which case having the crew survive is more important. I mean, what this is doing is it's basically for every point, it knows your destination, it knows the start point, it can figure out there's one orbit that will join those two locations. So you can figure out the delta V requirements of that orbit. The one thing that's missing, however, is orbits which may go around the Sun multiple times. So once you get up to very long transfer times, it's possible that there is a more efficient solution that actually orbits the Sun several times. And then, of course, it's obvious that there's solutions that may use gravity assists and things like that. Now, in academic literature, these are called pork chop plots. Now, they don't look a lot like pork chops, but that's because when these things were originally developed, they didn't have Technicolor printing that was generally used. Instead, they would have to draw gradient lines. You would have to draw contour lines. So you would draw a little one and then a bigger line, and these line drawings would kind of resemble cuts of meat with bones and things in them. So they would be called pork chop plots. They could have some very complicated shapes as well. Now MechJeb, it will also do this for you. It also has a maneuver planner menu, which it lets you calculate these things. Now you have to select your target from here. It computes it and it comes up with something very similar, but this one has come up with a completely different solution. In 1 year, it's 77 days away. So this is much sooner, but its orbit is interesting because it's going to take 1.5 kilometers per second, but it goes up high, and it looks to me like that thing is going to take much more delta V to perform the capture. So it's only optimizing one part of the trajectory, I'm guessing, and not the second part, let's say. There's maybe a way to access better tools, but MechJeb isn't going to solve everything. All the same, we'll just go with that because it's going to happen much sooner than the other one. Anyway, let's go back to this spacecraft. The Dreamchaser has a place to go now rather than in 77 days. So now we're going to try and return to the Kerbal Space Center. And of course we have this magnificent trajectory tool to help us put us in the right place. So normally we would just go over to the other side of the planet. We would wait until we were on the far side of the planet through time acceleration. There we go, 50 times time acceleration. And we would deorbit and we would put our periaps roughly 40 kilometers over where Kerbal Space Center is. That's usually a pretty good bet, but using this we can actually target the space center. So let's try this. We're gonna line ourselves up, fire up the engines, and we're doing this slowly just so you can see it happening. You see that we start to come down, our periaps gets lower and lower. What we're looking for is red, because red will indicate that we are no longer on a stable orbit. There we go. So that's coming down, and at some point that red line, there it goes, it starts to intersect the surface of Kerbin. And there you see it goes around, and we're going to land there. So let's bring that close to the Kerbal Space Center. Oh, and this thing is actually sensitive to my orientation because it accounts for the fact that I have wings. You can adjust your descent profile here, and that works again with Ferrum Aerospace and everything like that. But yeah, this is far too sensitive, and the reason it is far too sensitive, and in fact has disappeared, is because it's performing one complete orbit inside the atmosphere before landing. So I haven't been aggressive enough. I have plenty of fuel, so what I should really do is fire my engines once again and bring that target all the way around one more time, so we're performing a direct descent rather than this slow orbital decay onto the target. So yeah, we're going to put this over the space center and we should be golden. Bingo, there we go. Now of course, as I adjust orientation, it's going to shift that thing around because it's deciding that it wants to take my wing orientation into account for the descent calculation. Okay, well that's close enough. We do happen to have the ability to glide with this aircraft, so that's not, as long as we can get close to the space center, we're fine. We can still probably put it down on target. Now, for the descent, if you remember, I had this navball HUD which would let me, see my velocity vector, and I commented that that's actually very useful for landing because it means you can put your actual velocity vector rather than your pointing vector on target. However, I have this much simpler one which is just Kerbal flight indicators. This is providing a much simpler version. It has a green line for your for the horizon, it has a velocity vector, and it has a little roll indicator there. You see this? So I'm going to use this instead. It's much simpler, and I like simple, and I also like third-person view. So there's you see the roll indicator working, there's my velocity vector. So that's really the only things I care about, and you have similar vectors behind you if you're viewing it in rear view, if you're looking backwards. Oh yeah, and I have one other thing to show, and that will be the advanced chase cam, which will actually follow my velocity vector rather than requiring my mouse to adjust it. Anyway, I'm going to try getting down on target, And the only thing is, as I pointed out, as I adjust my attitude up and down, it's going to change where it thinks I'm landing. And so one way, if I pull the nose up here to turn a little, you see that it's actually slowing me down a bit. I'd like to turn because you can see that I'm coming in slightly south of the space center. And but turning at this point is going to slow me down more than anything else. Okay, so let's just keep this going. And there is no way to view the trajectory. I'm just checking. Yeah, there's no way to view this trajectory window outside of the map, so I have to keep going back to the map, unfortunately. Note to developer, would be really nice to see something like that while I'm actually flying. Okay, 4 times time acceleration, and we're going to just try and keep this target on the space center, or at least near to the space center as possible. So you can see that the wings are starting to make some changes, and so it's recomputing every time I make any adjustment, which is quite nice of it. Quite nice of it to make these computations for me. Okay, let's see, gotta keep this. I'm gonna try turning it, and you see that now that my velocity or my position landing vector is going further and further east, I'm starting to turn harder to make sure that I can use that extra velocity to put it north. There, look, it's right on target. Right on target. And I'm in re-entry mode here. Okay, so now actually I think I'm coming in too high and too hot. So I gotta slow myself down. Now I could just put my nose down and well, that would be absolutely valid, except that we're doing a re-entry. And at this point, if we're doing a re-entry, we should probably be putting my nose as high as possible so that we're, subjecting the underside of the aircraft to re-entry forces rather than those nice windows and solar panels and things like that. Okay, there we go, and we're still time accelerating. And I'm completely overshooting now. This is where things might get bad, because I might end up, if I can't get back to the runway, then I'm going to have to ditch in the ocean, and that is never going to be a good thing. Thankfully, I do have some fuel left, so I could probably use that to get back to base. All the same, though, it would be nice if I could not use my engines. And I'm actually going upwards now, so I'm going to do something really crazy and flip myself upside down and push my nose downwards, trying to dig myself into the thicker air down there and hopefully slow myself down a bit faster. Oh, no, man, we're flying over the top. This is not good. Well, let's turn this way. At the very least, if I do totally go too far, then I have the island runway. The island runway, however, is far too short and will probably result in me running off the end and into the ocean, which is never considered a good outcome. Sean Kerman and Bob Kerman doing their best to keep this thing and make it fly well. Okay. I am turning, though. I think this is looking good. I think if I'm going to just keep trying to turn all the way. The only thing is I'm descending too fast. When I turn, I'm going to need that altitude to provide energy. Remember, when you're flying, altitude is energy. And energy is life. Or something like that, right? If I was going down too far, then I wouldn't have the altitude to let me glide back to the target. But I think we're at 9 kilometers up. Okay, there's the chase cam. Let's fix this around. Yes, I'm turning on the chase cam now. So the chase cam means that I don't need to use the right button to keep turning the camera, because it will naturally follow my craft as it rotates. So there we go. We've got the velocity vector, and it is pointing at the airport. That is pretty good. So I think I'm going to have enough energy to glide all the way back. This thing clearly glides a whole lot better than the real thing. It's descending at about, I don't know, 50 meters per second. It's really hard to tell. So yeah, just put that velocity vector over there. So that lets me maintain a consistent glide slope the whole way, which is great. Rather than perhaps coming in and realizing I'm too high or too low at the last minute, I can use this like I would use an instrument landing system. There is actually an instrument landing system in the form of Kerbal Nav utils, which provides a whole lot of other really good things. It's worth looking at that if you want a more traditional instrument landing system, for example. And the nice thing about that is that there are configurations that let you work with the alternate Kerbal bases that have been produced by the community. I really should show you some of those at some point, right? There's someone that's put bases all over Kerbin, so you can experience the joy of launching from a highly inclined or a high inclination, a high latitude base. When you launch from a high latitude base, then your satellites all end up in a high inclination orbit, which may not be what you want. Indeed, you know, the Russians, they actually launched from Kazakhstan and, you know, Baikonur, and they can't immediately go west because then they will end up dropping stuff over China. So they actually have to go northwest and put themselves into an even higher inclination orbit. Okay, and that's why the space station is at such high inclination orbit, because they wanted to make sure that the Soyuz and the launch vehicles coming from there would be able to get to the space station. Ideally, they would have put it in a lower inclination orbit, but that didn't work. So yeah, this is me turning very slowly, and again, keeping that velocity vector in roughly the right location so that I will be able to land or glide down and flare. You just got to think of that velocity vector as where you will hit the ground. So it's extremely, extremely useful. Okay, so now I'm running out of things to say because I'm performing a landing, and this is never the easiest thing to do, but I think I'm going to be able to do this completely dead stick without any help of any engine fuel or any RCS for that matter. Look at that, we're 1.8 kilometers up. Our vertical velocity is still about 30 meters per second. So yeah, definitely much better than the real Dreamchaser. Okay, there we go. And the hard part now is I gotta line this thing up. We only get one go at this, even though I have engine. I'm gonna land this, I don't care. I'm not gonna use my engines to go around. Also, very important when you're building these tiny, tiny space planes, make sure you only have brakes on your rear wheels, because you've probably made your front wheel higher up so that it can lift off the runway, but when you're landing you need to have your angle of attack low enough that you are sinking towards the runway. There's the gear coming down, and if your angle of attack is too low and the front wheel touches and you brake on that, then you have some trouble. Okay, flare, bring the nose up, oh, two up. You've got to keep that velocity vector pointing down just a bit. And we're going to touch down. No, yes, is that touchdown? Okay, brakes. And we have successfully flown our mission. Of course, our little ion probe still has a long wait ahead of it, but that is my Kerbal Dreamchaser. I'm Scott Manley. Fly safe.